Hi everyone, I'm super excited to host Immanuel Koh. He's assistant professor at Singapore University of Technology and Design. I have been following your work since last 4 years from COVID, from digital future talks, and it's very inspiring to see the cutting edge work in AI, technology, and architecture you've been doing. So it's an honor to host you on the show. From your college days till date, what would you like to share, like the top career highlights?
Right. Maybe. Yeah, so my background is in architecture. So I studied at the Architecture Association at the AA in London. And that was sort of the first time that I had a very positive impression of programming because it's way more design related, way more creative. I would say that was the time that I honed my skills in coding, doing lots of like processing back then and that sort of stuff. And then after that I hang around, did quite a lot of workshops for like, after graduation and then almost stayed in Berlin for some time to work and then decided to go back to London. Actually, I went back to Singapore briefly and then I went back to London a year later, spoke to Patrick Schumacher, who was at my review, so he recalled my project, the final project, and then I joined Zaha, the architects for a few years. And so I've been teaching in parallel throughout my time in Zaha. So I was teaching coding at the AA, in the intermediate school. I was also teaching at the UCL, at the B Pro, Bartlett. I was also teaching coding at the Royal College of Art, the architecture department. That one's quite brief, about a year. Yeah, I mainly teach it at the AA and also postgraduate courses. Then, so I sort of, during that time, I was exposed to a much broader spectrum of how programming can be applied in a very different setup. So I was involved in interaction design, working with dancers, projection mapping. And that was the time where, yeah, I think I grew quite a bit, in terms of exposure. And then I decided that I would like to do a PhD. So, I went on to, EPFL, which is in Lausanne, essentially this French speaking side of the ETH. So it's the in Lausanne in Switzerland. And I started around 2016. And it was the time when I started out not knowing what I want to do. I sort of want to know. I surely want to do computational design, but I wasn't very clear. And it was at that point because I was in a lab where it's in both the computer science and also the Institute of Architecture. So I was teaching computer science students and I was also teaching architecture students. It was the time also when, if you recall, 2014 was the nearest style transfer, was again. So 2015, nearest style transfer, the earliest paper. And then also 2015 is also the first visual version of the GAN, DC GAN. And so I was sort of surrounded in, because I have friends in the computer science department, and so and they've like programs, events. So I was sort of introduced quite early on of deep learning. And then I was asked to do, so since I graduated from the AA, I've been teaching the AA visiting school for many years. And 2016, decided to do a deep learning workshop in Shanghai. So you could imagine in those days, it was very tough. Internet connection was terrible as well. And I was just running Dino or Lasagna. Back then, no Keras, no TensorFlow, no, not really PyTorch. PyTorch was just beginning. And in fact, some of the earlier founders, they were based in EPFL. And so I started the workshop doing that and it was very new. I mean, back then, my student, they were showing stuff at the final of, if you recall back then, there was the style transfer where you have a content image and a style image and things just slowly optimize and morph into something, right?
Mm.
From noise to something. And surprisingly, as much as the people in the jury were curious, they didn't quite understand. I actually recall back then, Newlish was there in 2016 at Shanghai. I mean, he wasn't too immediately kind of caught on with that thing. Tom Verbers, he was the director of the A Visiting School, Shanghai Visiting School. He appreciate a lot and he find it mesmerizing, but he didn't also quite understand like what the hell is that. So and then 2017 I began to introduce more three-dimensional forms with sort of sequence to sequence and do sort of discretization. And also back then I was teaching or supervising a thesis student in the EPFL computer science, and we're working on back then 2017 wave function collapse. And back
Oh.
then, wave function collapse was it started out by this Russian guy, and that was the only GitHub. So we decided to do a Unity version of wave function collapse. For in the first half of the research was just looking at the rule-based version. And then after that, if you're familiar with FC, is that there are actually two versions. One of the more interesting version is that given a single image, it began to compute the neighborhood probability so that it learns the correct neighborhood. And it's called wave function collapse, obviously, because it's inspired by quantum mechanics about contradiction and all that. So I introduced that, I think 2017 or 2018 at the A Shanghai Business School, and I learned my lesson that I should not install everything. So I basically have a Docker image, and it just ran quite quickly. Ran quite quickly for the end, produced quite interesting stuff, and then we link it to some architecture sample. That was the time when I began to sort of try to reconcile deep learning. I mean, if you recall early days, actually neural cell transfer is not heavy data. It's basically using a classification model to then optimize it by changing the in between layers, intermediate layers, to create this optimizing the model, the image to create the style and content that you desire. So it was the time where the small data of wave function collapse, the uh the no need for training data in the sense of neural style transfer, and then slowly with the DC GAN where you begin to have a need to have training data set.
Mhm.
So was very interesting. Yeah, I might be sharing too much, but basically that was the kind of the beginning. And then I decided that I'm going to do a PhD on deep learning. So my thesis is actually so the title is architecture sampling, and then the subtitle is a formal basis for machine learnable architecture, and I finished it in 2019. And obviously, if you're familiar with the title, is referencing Peter Eisenman, right, about the formal basis of modern architecture. Therefore, I was trying to discover if there is this idea of a formal basis of which we could learn architecture three-dimensionally. And the thesis work is mainly looking at different ways of sampling, combination of deep learning, but also using sort of multi-dimensional Markov chain to learn neighborhood relationship. So my final journey then is when I joined SUTD. So 3 months before my defense, I was hired to join the university. So I started teaching the first course in the architecture school called Creative Machine Learning. So 2019, I was just playing around with stuff. Back then was the first batch of students were playing VAE, variation
Mhm.
autoencoders. And then subsequent year, we were playing like GAN, and more recently, we're playing with obviously diffusion models, but also I would say in the past 2 years, things have changed quite tremendously. So I began to look at sort of not just vibe coding, but also agile way of learning coding while learning some high level understanding. So in the earlier iterations of the course, I actually make my student uh to code classification models to actually back then Keras was easier, so I introduced them Keras with TensorFlow, and they have to learn a basic understanding of what's a vanilla GAN, what's a vanilla classification model, or binary cross attribute, that kind of stuff that they should know. But increasingly things get I mean there's a lot of things to learn, right? So the every iteration of course there are more and more content to cover. So I
Mhm.
can't compress it further. I have to decide what to let go and what to move on. But anyway, so my journey, at SUTD, I started teaching. There was no AI courses in the architecture school, so they wanted me to do that. Started that, and then the following year, I told the university that it's good to have a hands-on coding class, but I think our students are missing the entire history of intelligent architecture. They have no clue about Cedric Price. They have no clue about Nicholas Negroponte. They have no clue about computer art. So I told them that let's do a history theory course on in parallel. The title is quite long. It's artificial uh, and architecture design, intelligence in design, and it's been going on. This term we're actually doing for that history theory course. We're doing some spatial reasoning benchmarking experiment. For the creative machine learning course, this term we are working on um, storytelling with Comfy UI and other stuff. Um, and then 2020, I'm not sure you are familiar with SUTD. In 2020, I think they created a program called Design AI degree program. It's a bachelor of degree, a bachelor of science in design AI, and our first cohort student graduated last year. It's a kind of a 4 year, 3 to 4 year course. And as of this year, the university basically steer to a new direction, building upon being the first in the world to have a Bachelor of Science in Design AI degree. The university is now the world first design AI university. So this year, there's sort of a drastic kind of a further reconfiguration, maybe to my advantage because this is actually my area of research. Not sure
Mhm.
about the other faculty, but essentially is useful. I'm actually so I'm also teaching in the design AI program since I'm teaching the upper year students. So yeah, after I joined the architecture school, I also jointly teach at the design AI program, which are mainly non-architecture student, but if you like, applied AI student who've been exposed to different kinds of design, from service design, system design, product design, and the last studio is spatial design, which is the one that I'm leading. So I work with industry partners to work on across the scale. From the most recent one, we have HKS Singapore working with us. The last year we had HKS Singapore among the 8 different industry partners. For the architecture, it was HKS, and the year before was Autodesk, the former engineering team, also and with SJ Group, which is a huge architecture. Well, actually, the full package. SA Architects, which is part of SJ Group. And then we have last year was the Singapore Art Museum. So this is kind of the long story.
I have like so many questions. From your journey, you have been always ahead and tinkerer with the new trend in AI and being early adopter and tester. It just made me curious to know if you were to recall the times where the output of the algorithm surprised you and like had a aha moment, what would that be?
In deep learning.
Yes.
So my earlier surprise was, I mean, I've seen many, but I mean, the real aha moment that is non-AI was when I was doing, and when I was at the AA. I was surprised by how coding can be so fun and you can actually create cool stuff. But if I were to consider an aha moment, it might be the 3D GAN housing project that I was doing because earlier on I had great difficulty. I mean, I actually did the 3D GAN for furniture for the earliest digital future, I think in the COVID era, I think 2020, I think so. And then I was all back then working on trying to scale this thing up. It was very difficult to scale it because you have to the bottleneck, the stumbling block was how to deal with the voxel resolution problem, right? I mean, you can't just go, 1,000. You can't just, and then you can't just stick to 72 by 72, right? Or 256 by 256. So that was the time when I have to deal with this problem, and I began to combine parametric model which solve the resolution problem via a parametric, a kind of an internal parametric model. Actually, neural networks, they are parametric model. But what I'm saying is that you actually split the problem into two parts. So you have the 3D gun voxels solving the overall massing problem. The other thing is also predominantly back then, every voxel has no semantic at all.
Mm,
It's either 0 or 1. So
yeah.
that was the time when I began to look at what does it mean to have semantics. It may not have any meaning to when you do a chair, but when you do housing, it is completely meaningful. You need to know the lift call, the corridor, the apartments, right? Where every boxer could represent something. And also the question on can a voxel represent to some degree, per story of a certain real life size? So that was a time where I figure out that it's actually possible if you have semantics in the 3D GAN, and you have also a separate parametric model that sort of solves the high resolution problem. And on top of that, I was also looking at literally at the probability distribution of the voxel. So if you know that, you could just take 1 or 0, but actually it's, softmax, right? So you can actually get the probability if you want. And
Mm.
that became very, as a way to further solve the problem. And then that is the project. Also, I also learned quite a bit in doing that, working on that project, is that you can't just linearly interpolate. You have to in a certain way in that latent
Yes.
space. And back then it was sort of based on a kind of arc to capture more interesting sample during the interpolation. So that was kind of the moment that you can actually use it for architecture, not just for, chairs and, objects.
Interesting. And there's so much, like, especially in past few years after the LLM diffusion wave, there's so many cutting edge research and a lot of applications of like in architecture space. We have seen in visualization, like they're like
Mm.
custom LoRa's trained for various tasks. What do you think is missing or area which there's not enough research in our industry?
Yes, I also experienced the kind of fatigue in this. I mean, I think it's useful. My students, they are training their own LoRa's as well for the creative machine learning course. I mean, these are useful, but there is probably a saturation of the, image to video, text to image, kind of mid journey. That space of the concept inspiration part is a bit too much already, and the other downstream thing are kind of neglected, right? So, for instance, I've got some papers that look specifically at graph neural networks. So how do we, which is kind of linked to my earlier interest in my own PhD thesis, is how do you decompose architecture so that you could learn them either this in a discrete way or in a continuous way. So in that sense, the some of these paper, one of them is called building GNN, one of them is called building graph variational encoders, is to try to figure out a systematic way of encoding architecture. So it is not as sexy because it's, I mean, volumetrically it's actually sexy, but image-wise not as sexy as the text to image, image to video. So I think a kind of serious thinking about how to encode and decode and what does it mean to have an architecture embedding? Things
Mm.
like this, right? What does it So in a way, I know there are gaps in the industry that we're not serious enough to want to deal with it. But there are also disciplinary gaps that we sort of turn away from. That just like in my own back then in my thesis, I was sort of referencing, okay, if image has pixels, if audio has the, frequency, the waveforms, signals, what is architecture sample?
Mm.
What is it? Right? And so my conclusion actually was that there is no notion of architecture sample. The sample is defined by you, whether you define architecture as a 3D volume or an atmosphere or a temperature, it's up to you. So
Mm.
that was sort of the kind of conclusion at the end of the thesis. It's about 500 pages long, so you guys can read it. But anyway, so that kind of thing is missing because if we don't do that, we are just appropriating. If you recall in the 90s, when Greg Lin started playing late 90s, playing with animation software, Maya and all that, it's one thing to adapt and appropriate, but what happened in those days was that these guys are very smart. They merge it with Deleuze philosophy, right? And so it gives it a different kind of a direction and perspective that kind of more strategically or relevantly align with the architecture discipline. But however, this is not quite the case. Now, we have people experimenting, myself as well, on sort of the image stuff, but there's no real desire to somehow theorize it. And of course, we also see problem of people trying to theorize, but are actually not in that space. So it's
Hmm.
a kind of surface theorization. Whereas those who are deeply in there seems not interested to theorize. So there is this about this kind of a strange dilemma. Yeah. So I think to answer your question, what is missing is a seriousness in asking disciplinary question about how do we encode decode architecture? Are we able to think about? I mean, my hope is that has always been my kind of in desire is that we work with AI models, and from that process, we begin to create our own architecturally relevant deep learning models. So I think that's kind of necessary so that we become part of, just like when early days, although quite different. Christopher Alexander, right? He contributed tremendously to object-oriented programming. So I still sort of naively believe that we can actually contribute also to the AI research, which that's why we're, in my lab, we also publish in NeurIPS and CVPR, IEEE, because I see there's a need to not just try to work at that level, but also be in the scene, to be
Hmm.
part of that community somehow, at least from a research perspective. And if we can do that, maybe we can steer our own future as a discipline that and also increasingly we know domain knowledge is actually very important. That's why I started working on, we call it the SUTD design brain. So it's sort of a university thing, is to try to understand spatial design reasoning. What is spatial reasoning? To the computer science people, spatial reasoning most likely is okay, you find an object in the scene and then not just detect it, but there's some physics thing going
Hmm.
on. But if you think hard, actually when we do design, right, we also simulate a process. We simulate relationships between objects in the scene. So there is a different, I mean, there is a rational, logical, physical kind of spatial reasoning, but there is also this analogical, metaphorical kind of conceptual reasoning that is inherently spatial, like of famous all these architectural diagrams from the 90s onwards, right? In fact, there's this whole book that was written by this to be published, I think, or published already by this ETH professor. The whole book is just about the arrow in the diagrams,
Hmm.
the arrow in the diagram in British architecture, for the past 30 years. That means arrow has a special spatial connotation when we try to reason as we draw the diagram or whatever.
Your each answer like provokes me like so many interesting questions. Especially like one of the realizations I had when I was testing with VLMs and clip encoders, the way they are trained, and we have a construction drawing detail with 5 details within the drawing. Some people just try and ask ChatGPT and answer it. Sometimes just doing OCR, it doesn't have the reasoning knowledge of how the details is composed or why like individual detail and the relationship. That made me feel like although we are training a lot on the visualization side, but for reasoning we need our domain specific encoder training which can signify all this knowledge of. So just
So
wanted to share that.
the recent paper we tested about 10 different VRMs, from Grok to Quen to Phi to Intern to turn out that, I mean, GPT 4 mini is still high, is still very good in terms of understanding and interpreting and reason the image. It's just like you say, right? So what we did in my lab is that when building that benchmark data set, we actually removed the text because
Oh.
then it's unfair, right? You have the OCR, but we also reach a point where perhaps text is part of that diagramming process. So maybe we should not remove it. And so it was a bit confusing. And also things like, we also found out that actually these models are very bad with collages because
Mhm.
it's unrealistic. It's unrealistic because it doesn't look at a real image because the shadow, the depth, they're all wrong, right? So
Mhm.
it actually quite bad with that. And some model perform particularly well in cross-referencing different images. So we did some experiment where, so instead of giving it a floor plan, you give it like a floor plan elevation section, and you force it to cross-reference. They usually do it quite badly, which we, as architects, we take for granted that we can easily cross-reference views of the same object and somehow synthesize that in our mind. Of course, there's a lot of discussion on spatial intelligence, like Kekeli came by Singapore just last week, and I attended her talk, and she was talking a lot about World Labs, right?
What else?
Spatial intelligence. But I feel that architecture can contribute to that spatial intelligence. Not just the robotics, not just the scene reconstruction or images. Yeah, maybe I'm just naive or just optimistic that architecture has a place. Still has a place.
Yeah, and like I think apart from your work, they only see like from Stanford or ETH, like who are like okay, as you were saying earlier, we have value to provide in like CVPR or big conferences because the objective function of autonomous vehicle or scene construction is different than what
Mm.
an architectural design layout, and but there's also an intelligence on why in which scenario the bet should be placed in this versus not that. And autonomous vehicle or scene reconstruction don't care why it's laying down. There's no reasoning in part of the training.
Yeah, but again, the reasoning has no. Often when architects talk or designers or artists talk, when in the talk we have, as we reason, there is some kind of a generative intention. I don't know how to describe it. That when we talk or draw, we are aiming to generate something. We're not just trying to explain. I mean, explain can come later. That's why we are the theorists, right? But that's why we'd say when you design or yeah, there's a flow, right? So there's a kind of generative flow inherent in how we've been trained as designers.
I have one thing I wanted to know. So right now with earlier, it was difficult to evaluate architecture design, the criterias. Now we can ask VLM, give 10 different design, and it can do scoring. Do you think architecture design or like visual layouts, we could objectively rate?
That's why for me the diagram is particularly interesting. Although it seems to be more kind of a more late 20th century kind of invention, because it's the ambiguity, right, of the drawing that granted uh, a bit of the generativity, if you like. Whereas, so if you, I mean, w- you can ask it to, for instance, we did some experiment where we give all this design and ask it to like click interrogator, generate image to text and just see what it's saying, right? And often it's quite disappointing because it's just describing. It's not saying more that is ambiguous. And often we want a certain degree of ambiguity in the evaluation. It's like if you've been any sort of a jury for a design competition, sometimes some design, they broke all the rules, right? But they're just amazing. So you can't verbalize every single reason why this is amazing and should be the first prize. A bit of that strangeness.
I have a rapid fire round to wrap up the interview, and the challenge is you have to keep the answer in 5 to 10 words max. So, what are your hot takes on AI agents for architecture?
Okay. AI agent, I think is amazing. It's almost a sudden, not revival, but a refreshing of the way in which we describe agent-based modeling in architecture. In fact, it's also last year there was a paper, right, from MIT, where the authors were trying to sort of have a kind of refresh of thinking that agent-based system is no longer the rule-based, flocking or whatever, right? But actually every agent can have an archetype persona, which you could call on the LLM to then create a society, essentially, in a way. But that's not the point of the paper. But the generative agent paper is extremely important because it hinted on the possibility of creating a society, which is kind of what we're trying to do when we design. We try to anticipate behaviors of people, right, in the buildings that we build in a way, and we try to understand, just that we have completely no control of it, right? And so my take on the agentic thing is, I think it's very cool because on the one hand, you could actually have autonomous designers. So another paper that will be published in IJAC soon, which is the International Journal for Architecture Computing in June, which I'm guest editing. That paper is about we created like four different agents: reasoning, visualizing agent. So you begin to have, if you like, sort of an artificial collective intelligence where there is indeed individual intelligence within each of the agent. Unlike
Mm.
old world understanding of agent-based modeling is like, just following rules, right? And they call it collective intelligence, which is true, but now it's a different kind of collective intelligence. And it's highly scalable. Suddenly it's possible to have millions of these agents, each of them having a different persona and each of them interacting with one another. And then you see how they evolve. And they can call on different LLMs. So that's even more crazy, right? So, and then every LLM, you could then do a standard, RAG or whatever to give it a bit
Mm.
more specific knowledge or rather character even. So in that case, it's very, it has good potential. I've also been thinking about it's this sort of autonomous thing could inherently be incorporated with blockchain way of thinking about collectives and transparent intelligence. You realize, yeah. So my hot take is great opportunities, but what do we do with it exactly at the architecture scale? Urban scale, okay. Architecture scale, if we just say is a co-designer, that's one thing. But I think it's still useful, definitely, especially on the reasoning part. So the project I mentioned, that the design brain project at SUTD, it's really about design reasoning. How we can have collective reasoning as some sort of a dialogue, and yet having those reasoning being transparent to the viewer.
Three AI researchers you admire.
In architecture or in computer science?
Like open.
I mean, although actually I like David Ha. I don't even know David Ha.
Yes, yes.
Now he's in the Sakana. I tried to invite him to Kedra last year, where I was chairing the Kedra is the computer architecture aided design in Asia conference. So I tried my luck, and then obviously didn't work. He's very busy. I think he's amazing because I mean I think his background was like in like financial. He's like a financial analyst or something, right? And then he's doing this. So I was already inspired by his work early on when he was doing some amazing kanji, with the VAE
Yes, yes,
generating
I've seen.
crazy kanji, right? And then, of course, he became very famous after that from his work in this large corporation. And more recently, he decided to leave and go back to Japan and start Sakana, right? And then his most recent paper, which is this collective it's like, it's madness, right? It's trying to learn the algorithms behind this, artificial life. So this is nuts. So I admire him a lot, but I mean, I don't know him in person, or, we spoke on the messages and all that email. So that's one. The other one, I don't know about the recent, I mean, I still very much like the GAN, when Ian Goodfellow, simply because it was so out of the blue. I mean, it's so original, right? I mean, and yes, now when the diffusion kind of, but as an idea is very beautiful,
Mm.
right? Generator discriminator is like, who have thought of that, right? And that was like 10 years already. I've not been following him in more, in recent years, but that has a major impact, in the way in which we think about generative modeling. So yes, of course, we have the standard heroes, intern and all that, but yeah, so that's why I'm sort of naming the more contemporary ones because those are already heroes of everyone, right? The heroes of
Mm.
heroes. A third one. I don't have a third one yet. I mean, I have
Karapathy.
quite a few. Yeah, but I mean, yeah, Kapati, but I mean, it was the chat RNN is still in my head, right? So the chat RNN, right? But the I don't know. In recent years, there's an increasing corporatization.
Yes.
Sometimes I feel that sometimes I listen to some of these heroes, right? Sometimes I feel that they are sort of kind of influenced by the corporate world. So it sometimes disappoints me a bit when they spoke about certain things. I mean, like, Jan LeCun, many famous, they are all very important. I studied their, like, LeCun, Jan LeCun, I studied his, Net 5 during my PhD. I
Mm.
really redraw the whole architecture just studying his CNN, right? I mean, those are very
Mm.
important years, but these days it's very difficult. I think it's very difficult for them because they are such important, famous people. And to be always politically correct is not easy. But
Mm.
anyway, that's a different that's a
Yeah,
different
whole different. Lastly, what would be your piece of advice for students who wants to stay relevant in our industry, who wants to be cutting edge in technology?
So I often give this advice of, especially for architecture students who may not have any background or experience. The way I see things are changing these days, with all this vibe coding stuff, right? So I don't even know. They, eventually you need to be that good in programming. I still necessary. But anyways, in any case, I think but this might be my bias, to be partly in academia and industry. For student architecture, obviously you start off in academia, which I think is a very healthy ecosystem that we had at the AA. So often they say when you finish at the AA, the part three is at Zaha, right? Kind of, right? Actually, you finish your part two, part three in Zaha, not the QP. Um, but there's a nice ecosystem, right? We're teaching, we go back to school and teach the student, and then the student that graduate are refreshed, and then they come and join the office, and then very healthy. So I still believe there's a very valid reason to have this cross exchange during and after graduation. And also for students, I think should try it's a bit different in certain university, but at least in EPFL, it's common that you just apply to different labs and then you do your masters or research project. And that's when you get exposed to different kind of way of working and also meet different interesting research fellow, research scientists. So I would say you try to get yourself involved in some of these that you have a gut feeling that you like it, and then do it, and then you find out if you like it or not. Uh, but in terms of learning process, I think I think there's an oversaturation of the kind of text to image or whatever, but we can't run away from the fact that we need to get our hands dirty, play with this stuff to have an understanding of how these things work, right? I mean, like that's why I force my students to test. Each team has to test like five different chat LM and VRMs. Make sure that two of them will fail in the way in which you design your architecture question.
Mm,
But so that they learn a lot, right? Because they learn about what's architecture knowledge. So the advice is just play with this stuff, but also begin to understand in parallel. Learn about some of the basics because we often ignore, at least for architecture student, we often just don't want to, typically architecture students are not so keen on the math, right? Typically, yeah, typically. So, which is actually difficult for those with architecture background. So I would say play around, get your hands dirty with those tools, and then after that, get a bit serious and try to understand, at least at high level, conceptually, how these different fundamental models, like whether it's a diffusion model or again, and then start to try your hand on fine tuning stuff. But obviously, certain things cannot be done because you just don't have the compute. So join the
mm,
lab that has the compute. Just do a lot more internship, and then when you graduate, maybe choose the right offices that would allow you to grow instead of being dumbed down because
mm.
they all don't understand, which is often the case. Senior management do not understand what the hell you're doing. They just want you to automate everything in the office, right? But they don't want you to play with, let's say, judgment model, because they don't know what you're gonna get. So you might waste like 1 week, and therefore they pay you, for 1 week of nothing, of doing
Yeah.
nothing to them, right? So be a bit more critical in choosing the right office. Choose those that are more progressive, even if it means a lower pay at the beginning. Yeah, like my advice.
I have one last one. What do you do for fun?
What do I do for fun?
Yeah.
Ah, what I do for fun? I don't know. These days, my life is sort of entangled with my work. So fun, good question. What do I do for fun? I mean, it's not a question of the hobbies, right? I mean, I like jogging. Recently, I had a fall, so I am resting. But I like jogging and running because usually I get new ideas. So for me, that's fun because, and then I go back to the desk, the drawing board to do stuff, right? So fun to me is that for me, fun is also doing project. I mean, I have a number of projects. Some are very, very practical. Some are in a sort of commission from, museums, art museum or gallery. So I like to do the kind of side project too, because I can quickly prototype stuff and then somehow introduce it back to, the very serious projects, which larger funding usually. So yeah, and I also like to discuss with my researcher. I yeah, to bounce back ideas. I like to yeah, I think I had fun with my lab researcher. I'm very grateful that I can have a lab with projects going on, so they get to play what they like. I get to play what I like.
That's a great environment. It was so insightful hosting you